How can a big airplane fly? The science that keeps us in the sky. Imagine standing next to a giant airplane, metal wings, massive engines, 400 tons over of pure weight, and then it lifts off. How on earth does something that heavy float in the sky? Today, let's explore the amazing science that makes flight possible. Explained simply, no physics degree required. A fully loaded airplane can weigh 400 tons. That's like stacking 70 elephants together. You might think the passengers make it heavy, but actually, most of the weight comes from fuel and the plane's metal body. Fuel alone can take up nearly half the total weight. One long flight can burn thousands of liters of fuel worth tens of thousands of dollars. That's why scientists are always trying to make flying more efficient and eco-friendly. When a plane starts its takeoff run, it speeds up fast, about 250 kilometers per hour before it finally lifts off. Once it's high in the sky, it cruises around 900 kilometers per hour, nearly 3 times faster than a bullet train. But why do planes fly so high, about 10 to 13 kilometers up? Because the air is thinner up there. Thinner air means less resistance, so the plane can go faster and save fuel. But if it goes too high, the air becomes too thin, and there's not enough lift to stay up. So the plane has to find that just right zone. All right, time for the magic word, lift. Lift is what pushes a plane upward against gravity. It comes from 2 main ideas: Newton's law and Bernoulli's principle. And don't worry, they're easier than they sound. When the wings move forward, they push air downward. And by Newton's rule, every action has an equal and opposite reaction. The air pushes the wings upward. Push the air down, the air pushes you up. Simple and powerful. That's why even a flatboard, if angled right, can lift, like when you stick your hand out the car window and tilt it. You can feel the lift. Here's another way to see it. The wing's top is curved and the bottom is flatter. When the plane moves forward, air on top has to go faster, while air below moves slower. Faster air, lower pressure. Slower air, higher pressure. And the difference in pressure creates an upward force lift. But here's the twist: some textbooks say air on top and bottom meet again at the back of the wing. That's not really true. Air doesn't race to meet up, it just flows faster because of the shape and angle of the wing. So both ideas, Newton and Bernoulli, work together to create that invisible hand, holding the plane in the air. Lift depends on 2 things: speed and angle. The faster the plane moves, the more air it pushes down. That's why planes need a long runway to get enough speed for lift. At just the right moment, the pilot tilts the nose slightly upward, increasing the wing's bite into the air. And boom, the plane rises. Ever notice airplane windows are always round, not square? That's not just for looks, it's for safety. Sharp corners create stress points, like cracks waiting to happen. When the cabin is pressurized, those corners would tear easily. Rounded windows spread the stress evenly, keeping the cabin strong. And that tiny hole at the bottom of your window? It helps balance air pressure between the inside and outside layers of glass. So next time you see it, thank that little hole for keeping your window from popping. Airplane mode and Wi-Fi in the sky. Please switch your devices to airplane mode. You've heard that line, right? That's because your phone sends tiny radio signals. That could mess with the plane's sensitive instruments. Is it likely? Not really. But in aviation, better safe than sorry is the rule. And yes, you can get Wi-Fi up there. How? The plane connects to satellites orbiting Earth, like bouncing a signal to space and back. That's how you can scroll TikTok at 11,000 meters above the clouds. Here's a fun thought: if you jump while flying at 900 kilometers, why don't you land at the back of the plane? Because you're moving with the plane and with the air inside it. It's the same reason we don't fall behind Earth's spin when we jump at home. You already have the same speed as everything around you, so you land right where you started. When you think about it, flight isn't really magic. It's teamwork between air, speed, and science. Wings bend the wind, engines push forward, and the laws of physics do the rest. Every takeoff is a leap of faith and a triumph of human imagination. The next time you watch a plane rise into the sky, remember it's not defying gravity, it's dancing with it.